We are going to learn about solving systems of equations by substitution. The goal of this is to isolate one variable in one equation and substitute it in the other equation. So let's say we have the problem 3x minus y equals 6 and y equals 3 minus 3x. I will label this equation 1 and will label this equation 2 so that it is easier to talk about which equation I am referring to. So how do we solve these systems of equations by substitution? Well, the first step is to isolate one of the variables. We have to isolate, which means keep on one side of the equal sign, either x or y. If we look at equation 2, y is already isolated, so we do not have to do anything further. So in equation 2, we have y equals 3 minus 3x. We can substitute the value of y from equation 2 into equation 1. So equation 1 is 3x minus y equals 6. So we can say 3x minus 3 minus 3x equals 6. We substituted the value of y from the second equation into y in the first equation. Then we get 3x minus 3 plus 3x equals 6. When we combine the like terms, 3x and 3x, we get 6x minus 3 equals 6. Then we add both sides by 3 to get 6x equals 9, and we divide both sides by 6 to get x equals 9 over 6. And when reduced, x equals 3 over 2. We solved for x, so we need to solve for the y value now. So we can plug x equals 3 over 2 into any of the original two equations to solve for y. So I will plug it in the first equation. The first equation is 3x minus y equals 6. When we plug x equals 3 over 2, we get 3 times 3 over 2 minus y equals 6. We get 9 over 2 minus y equals 6. Then we get 4.5 minus y equals 6. Then we can subtract both sides by 4.5 and get negative y equals 1.5. Then we divide both sides by negative 1 to isolate y completely, and we get y equals negative 1.5. So we got x equals 3 over 2, which we can write as x equals 1.5, since 3 over 2 equals 1.5, and y equals negative 1.5. So let's check our work. We will plug x equals 1.5 and y equals negative 1.5 back into equations 1 and 2. So equation 1 is 3x minus y equals 6. When we plug x equals 1.5 and y equals negative 1.5 in it, we get 3 times 1.5 minus negative 1.5 equals 6. And I put a question mark above the equal sign because we don't know if it's correct just yet. 3 times 1.5 is 4.5. So 4.5 plus 1.5 is 6. We then get 6 equals 6, which is correct. They do equal each other. Now let's plug x equals 1.5 and y equals negative 1.5 into equation 2. Equation 2 is y equals 3 minus 3x. When we substitute x equals 1.5 and y equals negative 1.5 in this equation, we get negative 1.5 equals 3 minus 3 times 1.5. This is equal to negative 1.5 equals 3 minus 4.5. We get negative 1.5 equals negative 1.5, which is correct. They do equal each other. Therefore, x equals 1.5 and y equals negative 1.5 are the correct answers. Let's try another example. Let's say we have the problem 5x minus y equals 1, and 3x minus 2y equals negative 12. I will label this equation 1 and this equation 2. How will we solve these system of equations by substitution? The first step is to isolate one of the variables. So let's look at equation 1 and let's isolate the y variable. So equation 1 is 5x minus y equals 1. We are going to isolate the y variable, meaning that we're keeping y on one side of the equal sign and everything else on the other side of the equal sign. So we are going to subtract by 5x on both sides to get negative y equals 1 minus 5x. Then, we will divide both sides by negative 1 to get y equals negative 1 plus 5x. Or we can rewrite this as y equals 5x minus 1. Now we have one variable isolated. Then, I will substitute this equation inside equation 2 for y. Equation 2 is 3x minus 2y equals negative 12. So when we substitute the first equation inside equation 2, we get 3x minus 2 times 5x minus 1 equals negative 12. When we distribute, we get 3x minus 10x plus 2 equals negative 12. When we combine the x terms, we get negative 7x plus 2 equals negative 12. When we subtract 2 on both sides, we get negative 7x equals negative 14. When we divide by negative 7 on both sides, we get x equals 2. We solved for x, so we need to solve for the y value now. We can plug x equals 2 into any of the two original equations to solve for y. Let's plug it in the first equation. The first equation is 5x minus y equals 1. When we plug x equals 2, we get 5 times 2 minus y equals 1. We get 10 minus y equals 1. When we subtract by 10 on both sides, we get negative y equals negative 9. And when we divide by negative 1 on both sides, we get y equals 9. So we got x equals 2 and y equals 9. Let's check our work to see if our answers are correct. So we will plug the values in equation 1, which is 5x minus y equals 1. When we plug x equals 2 and y equals 9 in it, we get 5 times 2 minus 9 equals 1. We get 10 minus 9 equals 1, and we get 1 equals 1, which is correct. 1 does equal 1. So let's look at equation 2. Equation 2 is 3x minus 2y equals negative 12. When we plug x equals 2 and y equals 9 in it, we get 3 times 2 minus 2 times 9 equals negative 12. We then get 6 minus 18 equals negative 12. And we get negative 12 equals negative 12, which is correct. Negative 12 does equal negative 12. Therefore, x equals 2 and y equals 9 are the correct answers. Let's try another example. Let's say we have the problem y equals 2x minus 9 and 8x minus 4y equals 6. I will label this equation 1 and this equation 2. How will we solve this problem by substitution? The first step is to isolate one of the variables. If we look at equation 1, which is y equals 2x minus 9, the variable y is already isolated, so we do not need to do any additional work. Then, we will substitute the y value in equation 1 into the y value in equation 2. Equation 2 is 8x minus 4y equals 6. We will then get 8x minus 4 times 2x minus 9 equals 6. When we distribute, we get 8x minus 8x plus 36 equals 6. 8x minus 8x is 0, so we get 36 equals 6. This is interesting. We get the x terms canceled out with each other, and in the end, we don't have any x terms left. We are left with 36 equals 6. In this case, 36 does not equal 6. So the system of equations has no solution. Therefore, the answer is no solution. Let's try another example. Let's say we have the problem x equals 2y plus 4 and 2x minus 4y equals 8. I will label this equation 1 and this equation 2. How will we solve this problem by substitution? The first step is to isolate one of the variables. If we look at equation 1, which is x equals 2y plus 4, the variable x is already isolated, so we do not need to do any additional work. Then, we will substitute the x value in equation 1 into the x value in equation 2. Equation 2 is 2x minus 4y equals 8. We will then get 2 times 2y plus 4 minus 4y equals 8. When we distribute, we get 4y plus 8 minus 4y equals 8. 4y minus 4y is 0, and we are left with 8 equals 8. This is also interesting. We get the y terms canceled out with each other, and in the end we don't have any y terms left. We are left with 8 equals 8. In the last problem, we had 36 equals 6, and since 36 does not equal 6, we concluded that the system of equations has no solution. However, this problem is different. In this problem, we have 8 equals 8, and since 8 does equal 8, there are an infinite number of solutions to this problem. Therefore, the answer is infinite solutions.